Ever wondered what an entity type in database systems is? Well, allow me to shed some light. Within the realm of database systems, an entity type is essentially a category of things or objects that hold relevance to the business or application being modeled. These entity types represent the different kinds of objects or entities that the database needs to capture information about. Each entity comes with its own set of attributes that describe its characteristics or properties. Entity types form the cornerstone of the entity relationship model, a widely used conceptual modeling technique in the world of database design. Whether it's a customer, a product, or an employee, each entity type represents a distinct concept within the domain being modeled. Now, isn't that something to ponder over? Well, don't just sit there with your gears turning. Now, let's delve deeper into the attributes of these entity types. So, what exactly are the attributes of an entity type? Well, imagine the attributes as the fine details that paint a vivid picture of each entity. They are akin to the specific characteristics or properties that bring each entity to life. Each attribute gives us a piece of information about the entity it's associated with, providing us with a more in-depth understanding of it. Take, for instance, the entity type employee in a business database. The attributes of this entity type could include employee ID, which acts as a unique identifier for each individual. Then there's the name, which tells us who the employee is. Date of birth provides insight into the employee's age, and position gives us a clue about their role within the organization. Salary, another potential attribute, reveals the financial compensation the employee receives. But it's not just about names and numbers. Attributes can also be descriptive, like skills, which could list the employee's particular expertise, or hobbies that may hint at their personal interests outside of work. Attributes are highly versatile and can be virtually anything that helps us better understand the entity. Whether it's a customer entity with attributes like CustomerID, name, address, and purchase history, or a product entity with attributes like product ID, product name, price, and stock level. Each attribute adds a layer of detail that helps us distinguish one entity from another. Attributes can also be multi-valued. For example, an employee could have multiple skills, or a product could come in various colors. Multi-valued attributes add another level of complexity and richness to our understanding of the entity. So attributes are like the DNA of an entity type. They define the entity, giving it its unique identity and characteristics. They're the building blocks that allow us to create a comprehensive, detailed, and nuanced picture of each entity in our database. Attributes are essential, but they're not the only thing that defines an entity type. Let's talk about identifiers. What distinguishes one entity from another of the same type? This question leads us to the concept of identifiers in entity types. Identifiers, also known as keys, are unique attributes that set each instance of an entity apart. Think of identifiers as the special badges each entity wears. No two entities of the same type can share the same badge, making them easily distinguishable. To illustrate, let's consider a database modeling a company's employees. The entity type here is employee, and its attributes might include name, date of birth, and employee ID. While several employees might share the same name or even the same birth date, the employee ID must be unique for each individual. This unique employee ID is the identifier in this context. Similarly, in a retail business database, the customer entity type could have attributes like customer name, contact number, and customer ID. Here, customer ID serves as the identifier. It ensures that each customer is distinct, even if two customers share the same name or contact number. In both these examples, the identifiers employee ID and customer ID are essential for distinguishing between different entities of the same type. They ensure that each entity is unique and can be individually tracked or referenced. Identifiers also play a crucial role in establishing relationships between different entity types, which we'll touch upon later. For instance, the order entity might use customer ID as a foreign key to establish a relationship with the customer entity, linking each order to the customer who placed it. So identifiers are not just labels. They are vital tools in database design, ensuring uniqueness, facilitating data retrieval, and enabling relationships between entities. It's important to remember that while we often use examples like employee ID or customer ID, identifiers are not limited to numerical or alphanumeric values. They can also be composite, meaning they are formed by combining more than one attribute. Identifiers uniquely define entities, but how do these entities interact with each other? Let's find out. How do entity types relate with each other? In the intricate dance of database design, entity types don't exist in isolation. They can form relationships with other entity types, creating a web of interconnected data that mirrors the complexity of the real world. These relationships are the invisible threads that bind different entities together, defining how they interact within the database schema. Let's take a university database as an example. In this context, we could have a student entity type. Each student has attributes like student ID, name, and major. But students don't exist in a vacuum. They're part of a broader academic ecosystem. So we could define a relationship between the student entity type and a course entity type. This relationship could represent the fact that students enroll in courses. Now, this relationship isn't a one-way street. Courses also have students, right? So the relationship between student and course is reciprocal. The course entity type could have attributes such as CustomerID, course name, and instructor, and it also has a relationship with the student entity. This example shows how relationships between entity types can reflect real-world interactions. But it's not just about showing that these relationships exist. It's also about understanding the nature of these relationships. Are they optional or mandatory? Can a student enroll in multiple courses? Can a course have multiple students? These are the kinds of questions that help us define the rules of engagement between our entity types. And it's not just about students and courses. In a business database, a customer entity type might have a relationship with an order entity type, showing that customers place orders. In a healthcare database, a doctor entity type could have a relationship with a patient entity type, indicating that doctors treat patients. The possibilities are as varied as the domains we're modeling. These relationships are crucial, but how many instances of one entity type can be associated with another? Let's explore cardinality. What does cardinality mean in the context of entity types? Great question. Cardinality is a fundamental concept in the world of databases, particularly when dealing with entity types. It's all about counting, not sheep unfortunately, but instances of entity types. When we talk about cardinality, we're referring to how many instances of one entity type can be associated with instances of another entity type. Imagine you're at a party and you're trying to figure out who knows who. Cardinality is like your guide to the social network of entity types. Now, cardinality can take on three main forms: one-to-one, one-to-many, and many-to-many. Let's break these down a bit. A one-to-one relationship is like a perfect pair. Think of it as a monogamous relationship between two entity types. For example, in a database for a small company, each employee might have a unique employee ID. This is a one-to-one relationship. Each employee maps to one unique ID, and each ID maps back to one unique employee. Next, we have one-to-many relationships. This is where one instance of an entity type is associated with multiple instances of another entity type. In a university database, for example, one course could be taken by many students. So one course can have a relationship with many students, hence a one-to-many relationship. Lastly, we have the many-to-many relationship. This is where multiple instances of one entity type can be associated with multiple instances of another entity type. Think of a bustling city intersection, with multiple roads converging. In a book database, for instance, a book could have multiple authors, and an author could have written multiple books. That's a many-to-many relationship. So, to sum up, cardinality helps us understand the relationships between entity types in a database. It's like a roadmap, showing us how one entity type is connected to another, whether it's a one-to-one, one-to-many, or many-to-many relationship. Now that we've covered the key aspects of entity types, let's summarize what we've learned. Let's recap what we've learned about entity types. In database systems, an entity type represents a category of objects with shared characteristics or attributes. It's a core concept within the entity relationship model. Attributes are key pieces of information that describe the properties of each entity. For instance, the employee entity type might have attributes like employee ID, name, or date of birth. Additionally, entity types often have one or more identifiers, also known as keys. These are unique attributes that distinguish each instance of the entity. Relationships between entity types define how these entities interact within the database schema. And then we have cardinality. which specifies how many instances of one entity type relate to instances of another. Examples of entity types can range from customer, product, employee, to order, patient, and invoice. Now you should have a good grasp of what entity types are in database systems and how they function.